In today's lesson, we're going to go through the quotient rule, which is similar to the chain rule and the product rule in that it allows us to take the derivative of a certain kind of function. And as you can guess from the name, the quotient rule, this is going to be about dealing with quotients. So the first thing that I have here is I have sort of written mathematically what this looks like. The quotient rule tells us that this is how you take the derivative of a quotient. And I'll be honest, that formula looks really scary. It looks frightening. And so I'm going to jump right to the sort of the English version of this. Many students end up remembering the quotient rule through a rhyme, right? And so if you imagine that there is a high function, f of x, that's on top, and a low function, g of x, that's on the bottom, you can use this little rhyme to figure out how to do it. So the rhyme says low d high. So low d high means that you take the low function g of x, so you see that low function here, and then d high means the derivative of the high function. So low d high means you take the low function times the derivative of the higher function. And then minus high d low. Well, high means you would take the high function, the top function, and multiply by the derivative of low, d low, the bottom function. Then square the bottom. That just means that you square the function that's on the bottom, and then away we go means that you're done with it. So if you follow this rhyme, this low d high minus high d low, square the bottom, and away we go, you end up being able to do the quotient rule pretty simply. Again, it sounds bad, but as we get into examples, I hope that you'll see that it's pretty straightforward. So I have my first example here, and I've got all of our structure set up for it as well, so we can sort of see what all the pieces are. So we're going to start with what's the top function, what's the high function. So in this case, my high function is 4 minus 5x. And then we have our bottom function, our low function, is 3x minus 1. Okay? Now, our rhyme says we're supposed to do low d high minus high d low, so I'm going to need to know what the derivatives of these things are also. So if the top function, if the high function was 4 minus 5x, what's the derivative of that top function? That would be minus 5. Negative 5 rather. And then similarly, if the low function is 3x minus 1, d low is going to be 3. Okay, so now when we say put this information together to take this derivative, now that I have all this stuff written down, we will have low 3x minus 1 d high minus high d low, square the bottom, and away we go. At this point, you're basically, you've taken the derivative. This is the derivative. All that's really left is for us to actually go through and make this a little bit prettier, to clean this up a little bit. I'm going to start by cleaning up this f prime of x. Sorry, that was really terrible. I'm going to do this by sort of distributing the things that are happening on top. So this first one that I have here, when I distribute this negative 5 to both of them, I'll wind up with negative 15x plus 5. On the second one, it's a little bit funky. There's a 3 that's going to get distributed, and there's also this negative that's going to get distributed. So I think you should think of it as basically a negative 3 being distributed. So when that negative 3 gets to the 4, I'll get minus 12. And when that negative 3 gets to the negative 5, I'll get plus 15x. And then in the denominator, I still just have this 3x minus 1 squared. Okay? So now that I have this, my next step is going to be to sort of simplify further, right? So I'll have f prime of x. On the top, I've got some like terms. Oh, wow, that's awesome. There's a negative 15x and a positive 15x. Those are just going to drop out. And then we have these other two things. We add those together. We're going to wind up with negative 7 over 3x minus 1 squared. And that's it. That's our derivative. Like, this is the quotient rule. So for the quotient rule, you identify what the top function is, what the high function is, identify the low function, take the derivatives of both of them, and then use the rhyme to carry you through the rest of the problem. So the rest of this video is just going to be going through several examples of this. So let's carry on. Here's my next example. If the function g of x is e to the x over cosine x, find g prime of x. So just like we've done on these other problems, we're going to start by identifying what is the high function, what is the low function, and then we'll take those derivatives. The high function is e to the x. The low function is cosine x. The derivative of e to the x is e to the x. The derivative of cosine x is negative sine x. Now that I have all this information sort of written out for myself, I just follow my rhyme. The derivative is supposed to be low cosine x, low d high minus high d low, square the bottom, and away we go. So again, like, you follow the rhyme, you write down the pieces. It's a little bit ugly. You're dealing with a fraction here, but mathematically this shouldn't be too big a deal. At this point, all that's left for us to do is go back and sort of beautify this a little bit. This first term, e to the x cosine x. Over here I have a negative times another negative. This is effectively going to be plus e to the x sine x over cosine squared x. And you guys have seen me in the other videos. I really like, in as many ways as possible, to simplify these things. I noticed that in the top, there's an e to the x in both of those, so I'm going to prefer to factor that out. Make this e to the x times cosine x plus sine x all over cosine squared x. And there it is, our derivative of the original g of x function. If you haven't given yourself an opportunity to try one of these on your own, go ahead and give this one a shot. The natural log is going to give us, an extra fraction in here, so it might be a little bit complicated, but if you're careful about your work, you should be able to get through it fine. So I'm going to start again by identifying what the high function is and what the low function is. My high function is natural log x. My low function is x to the fourth. The derivative of natural log x is 1 over x, and the derivative of x to the fourth is 4x cubed. So now when I go to do h prime of x, I'm going to have low d high. The derivative of the high function is 1 over x. Okay, so low d high minus high d low, square the bottom. And in this case, x to the fourth squared, that's actually going to be x to the eighth. So we'll remember that in our next step for simplification. So h prime of x here, let's see here. That first term is going to give us x cubed. This next one is minus 4x cubed natural log x. And this is all over x to the eighth. At this point, hopefully you notice that there's a common factor here. The top and the bottom are both divisible by x cubed, so I can divide x cubed out of all of these things. So if I cancel that x cubed out, I'll wind up with 1 minus 4 natural log x all over x to the fifth. Once again, we have our derivative for this thing. We write down the high and the low, we write down the derivatives, we follow the rhyme, we win. This is my last fairly normal example, and then we're going to get into ones that are a little bit more complicated. This one's all trig, but it's also going to show us something that we've seen before. I won't tell you what that is yet, but let's go ahead and take this derivative. So my high function is sine x, and that means that the derivative of that is cosine x. My low function is cosine x. My derivative of that is negative sine x. So when I go to do the derivative, I'm doing low d high minus high d low, square the bottom, and away we go. There is some simplifying we can do on this one. In the numerator, I've got cosine x times cosine x, so that means I have cosine squared x. Over here, I have negative sine x times negative sine x. That's plus sine squared x over cosine squared x. And those of you that remember your trig well will hopefully notice something special is going to happen on top there. What is cosine squared x plus sine squared x? Hopefully you recognize that's 1. This is 1 over cosine squared x. Now the thing that you might have noticed is from the very beginning, we kind of knew what sine x over cosine x was from the beginning, didn't we? All along, this is f of x equals tangent x. Well, early on, we talked about the fact that the derivative of tangent x is 1 over cosine squared x. The quotient rule basically lets us see that. We get to sort of prove that for ourselves. So like I said, this is my last sort of basic or simple example of this one. The next ones that we do are going to have a little bit more complexity to them. I mentioned in some of the other videos that the quotient rule and the chain rule and the product rule, they don't live in isolation. They sometimes get mixed up with one another. This problem definitely has a quotient rule that's going to happen in it because there's a quotient, there's a top and a bottom. But hopefully you notice that there's also something going on the bottom. you notice that down there in the bottom, there's an e to the 5x, and that's going to require a chain rule. So as we go through this one, we notice that ultimately this is really a quotient rule problem. My high function is x cubed minus 1, and my low function is e to the 5x. So when I go to do the derivative of this, the derivative of x cubed minus 1 is going to be 3x squared. The derivative of e to the 5x, this is going to take the chain rule. This is going to be e to the 5x times the derivative of what was inside, times 5. In other words, d low is going to be 5e to the 5x. Okay. Now that I've got these two pieces, we're going to follow our rhyme, just like we have on every other one of these problems that we've done so far today. G prime of x is going to be low d high minus high. I want to make sure everybody notices there. Notice that when I did that, I'm putting parentheses around that. That whole thing has to be there. So we have high d low. My d low is 5e to the 5x. Sorry, that's a multiplication right there. Square the bottom, e to the 5x squared, and away we go. So I'm going to go back through here and check my work here. This was low d high minus high d low, square the bottom, and away we go. Awesome, yay. My rhyme worked. I wrote everything down right. Okay, great. Our next step here is to go through and try and simplify this a little bit. This is kind of messy. There's a lot that's going on here. Let's go ahead and do the top via the distributing that we've talked about before. This first term here is going to be 3x squared e to the 5x. And then over in this next one, remember that you're going to have the negative being distributed and also the 5e to the 5x. So you're basically going to be distributing a negative 5e to the 5x here. So I'm going to wind up with negative x cubed times 5e to the 5x. And then I'll end up with positive 5e to the 5x. And this is all over e to the 5x squared. Okay? I'm going to get myself a little more space here. The next thing that's going to happen is in the numerator, I'm seeing that all those things have an e to the 5x. So if I factor out that e to the 5x, what I'm left with is 3x squared minus x cubed plus 5. And this is all over e to the 5x squared. All along, I should have been writing g prime of x for these things, just to be precise and to be careful. Last thing I'm seeing here is that the top and the bottom both have a factor of e to the 5x. I can cancel one of those factors out, and my final answer here, 3x squared minus x cubed plus 5 over e to the 5x. So this was an example of a problem where there was a quotient rule that had a chain rule that was kind of built into it. And so you guys need to be on the lookout for that. In the next problem, we're going to see one where the quotient rule and the product rule are going to come in contact with one another. So here's the last example that I have. And if you haven't tried some of the other ones on your own, make sure you try this one on your own. The big piece of advice here, I would say, is please, please, please watch your parentheses here. It's going to end up being really, really important. So my high function here is x cubed e to the x. My low function is sine x. Okay. The derivative of the high function, you guys notice that's going to take a product rule, right? I'm going to do 3x squared e to the x plus x cubed e to the x. I was just letting those guys take turns being the derivative. The derivative of the lower function is really easy. D low is just cosine x. Okay. So now when I go to take my derivative, when I go to do my rhyme, h prime of x is going to be low sine x d high. Well, d high is this entire thing. So this needs to be sine x times all of that. Okay? So I have low d high minus high d low, square the bottom, and away we go. we could probably stop right here. Again, in some sense, this is functional. That is a derivative. We can go back and clean it up a little bit. I don't want to take forever in cleaning these things up. So I do think I want to look through this and see if I can pinpoint exactly what I could factor out. Right? When you look at sort of this factor and this factor, what do you notice they have in common? I notice that they both have, that all of these terms have an e to the x in them. And I also notice that they all have x squared, there's x cubed, there's x cubed. There's sort of like an x squared and an e to the x in all of those terms that are up there. Now, I'm going to skip a few steps here, but if I were to factor out that x squared and the e to the x, what would I have left of this first term here? There would be the 3 from the 3x squared, and there would be the sine x that was out here from the beginning. From this second term over here, there's the x, because it was x cubed and I only took out x squared. So there will be x sine x. And then on my very, very last term over here, there's the x left over and the cosine x. And I would still have my sine squared x in the denominator. Okay. In general, the last step of simplification isn't necessary, but especially as we're preparing, for the IB higher level exams and for some other higher level things, us being able to simplify things like this is a valuable skill. So hope that all made sense, and I wish you best of luck as you practice these problems.